All right, welcome back. So we're going to do a couple more examples. Next one. Now here we're going to write it in terms of the differential operator, the d. Okay, remember d dx. So we're going to find a general solution for d plus 1 squared, d minus 6 cubed, d plus 5, d squared plus 1, and d squared plus 4 acting on y equals 0. This is actually unnecessarily long. Let's actually change, let's get rid of this at least, and get rid of this one. Make it a little shorter. So this is not quite 16. This is 16 prime, because it gives you everything, but that other one was just way too long, okay? So we're gonna have 1, 2, 3, 4, 5, 6 linearly independent solutions, okay? This one gives us a repeated root. So we're gonna have our y of x is going to be c1 e to the 6x plus c2x e to the 6x plus c3 x squared e to the 6x plus c4 e to the negative 5x. That's from this one. Now this one, that's going to be plus or minus 2i, so similarly to one of the other ones. C, where we have 5 cosine 2x plus c6 sine of 2x. Okay, so we have, like we said, 1, 2, 3, 4, 5, 6 independent solutions. Okay, all right, let's take a look at 18. I think I might have to prime it as well. And by prime it, I just mean get rid of some of the unnecessary stuff that I don't like. So they've got d minus 1 cubed, d minus 2, d squared plus d plus 1, okay, d squared plus 6d plus 10 cubed acting on y equals 0. Okay, all right, so let's get rid of this d minus 1 cubed and this d minus 2. Okay, you know what that's going to give us. I hope. Okay, the d minus 3 cubed gave us terms similar to these three, right? Except for with e to the 3x. And the, the d minus 2 would have given us a term like this with an e to the 2x, okay? But these two are interesting enough on their own. Okay, so let's factor. We're going to need to factor r squared plus r plus 1, okay? So when we solve this, we're going to do the quadratic equation. R equals what? Negative 1 plus or minus square root of 1 minus 4 all over 2. Okay, so negative 1/2 plus or minus 3/2 over 2. We're also going to need to solve r squared plus 6r plus 10 equals 0. So there, that's from this one, of course, right? So there we're going to get r equals negative 6 plus or minus square root of 36b squared minus 40 over 2. So that's going to be -3 plus or minus 2i. Now, one thing that's interesting, that one's going to have cubed. Okay, so that's one of the things that's interesting here. So now let's start writing our general solution. So our y of x equals e to the negative x over 2 cosine square root of 3 over 2x plus, ooh, I should have had a C1 there. Sorry about that. Plus C2 e to the negative x over 2 sine square root of 3 over 2x. Okay, now those are the terms from this. Okay, now let's do the terms from this one. Plus C3, let me write it down there. It's hard for me to not say PO. So C3 e to the negative 3x cosine 2x plus C4 e to the negative 3x sine 2x. But look, we have that cubed. Okay, so that means I'm going to need multiply by x and x squared. So C5x e to the negative 3x cosine 2x plus C6 x e to the negative 3x sine 2x plus C7 x squared e to the negative 3x cosine 2x plus C8 x squared e to the negative 3x sine 2x. Okay? All right. That's it for 6.2. I will see you guys in the next lesson. There are, of course, before I go, there are initial value problems, but there's nothing to them, right? You just, once you have the form, you plug in the initial conditions, you get a matrix equation, you solve that using whatever matrix solver you want, okay? All right, I will see you guys soon. Bye now.